Hi, my name is Andrew Hall, and I'm a program manager on the Visual Studio Debugger team. You likely use breakpoints as part of your every debugging in Visual Studio. Today, I'm going to show you improvements we've made to configuring breakpoint settings in Visual Studio 2015. So let's jump straight to Visual Studio and take a look. So here we are in Visual Studio 2015. I have an application that I've written that's going to encode and decode information that's passed between a client and server application. And I've run my first test, and I can see that it's failed at character 75. So it's failed to encode and then properly decode character 75. I'm going to jump right into Visual Studio and debug that using breakpoints and the debugger. I'm going to start by setting a breakpoint in the apply byte shift function, and notice that this toolbar pops up off the top right side of the breakpoint icon. There's two things I can do from the toolbar. I can choose to open the settings, or I can choose to disable and then enable the breakpoint. So I never have to go to the context menu to do this. It would pop up and then fade away if I did this from the keyboard. In fact, you notice as I move the mouse away, it fades away. When I move the mouse back, it comes back. If I prefer the context menu, you can see that the settings have all been consolidated under a single entry. If you've used breakpoints in previous versions of Visual Studio and ever configured any of the conditions or actions available to you, you remember that each possible setting was its own context menu. I'm going to go ahead and open this, and we can see the consolidated UI. The first thing to notice is that it appears in what we call a peek window. It's not covering code. It's not modal. You can see that it's between line 87 and line 88. I can still interact with my editor. I can type if I want. I can highlight things. If I wanted to copy and paste snippets of code in as a condition or an action, I would be able to do that. So the next thing, I mentioned conditions and actions. You'll notice that the UI of the breakpoints window is laid out according to this concept. If you think about breakpoints are always the concept of a condition and action. You're asking the debugger when execution reaches a certain point to break execution. So your condition is execution reaches this point. Your action is to break execution. We have additional conditions and actions that you can perform in your breakpoint that can potentially improve your productivity while debugging by reducing the amount of time that you have to break and inspect information manually in the debugger. Let's take a look at the conditions first. So the conditions available to me are a conditional expression, which is conceptually anything you can type inside an if statement in your application you can enter here. So the example says x equals 5, but I could choose to be more complex than that. I could say byte to mask equals 75, for example, and true and not false. I could do as many things as I want. They just need to evaluate to a Boolean expression. The other option I have is hit count. This tells the debugger to break after the breakpoint's been hit a certain number of times, and then I can choose to do that when it's equal to a certain number, it's a multiple of a certain number, or it's greater than or equal to a certain number. This is useful when I have a general idea, or I know exactly how many times something's being called, or the iteration that something's failing on, but I may not have an exact condition that I would use in the conditional expression. So in this particular case, I know that apply byte shift is failing on the 76th time it's being called, so it's 0 based, and it's character number 75. But I'm not exactly sure if the problem's higher up or lower down, so I'm going to use a hit count breakpoint here to debug this in a minute. The final type of condition that I have is called a filter breakpoint. A filter breakpoint lets you tell the debugger to break based on the machine, process, or thread information. And this is really useful when you're debugging shared code that may be running in parallel, whether it's in different processes, on different threads, or on different machines. So let's go head back to hit count and specify a hit count of 76. And notice as soon as I press enter, the settings just committed. I could start debugging, and the breakpoint would be hit. So I'm going to go ahead and do that. And I can see that the current hit count is 76. And I can see that the byte to mask is 75, exactly as I thought it would be. So right away, I didn't have to close the UI. I was able to just start debugging immediately. If I wanted to close the UI, I just click the X up here, and it goes away. So the next thing I want to do is create a breakpoint that does an action. So I'm going to go ahead and add my action to the existing breakpoint that I have, because I'm able to combine my conditions and my actions in Visual Studio. So the actions that I can do in Visual Studio at this point is to log a message to the output window. So instead of stopping and inspecting stuff manually under the debugger every time, I can just tell the debugger to print it And then by default, this checkbox down here is checked that tells it to continue execution. So I never have to stop. I just get to go look in the output window. And this is really useful if you need to understand a large number of things that are happening where it might be tedious to stop, break every time, see what's happening. So there's three types of text that I can put on my message. I can put plain text that will be printed exactly as I type it. So in this particular case, I'm going to type the message that says encoding. And then the second type of information that I can put is variables in my application that the actual value will be printed. So I want to say byte to mask, and that's going to print the value of that character. And then I want to show what it's being encoded to, and I want to say masked. And then the final type of information available to me is what we call a pseudo variable. This is I get this by putting a $sign in front of the variable name, and then the debugger is going to go ahead and expand these out to whatever I've chosen. So I'm going to choose function here, so it's going to tell me what function that we're executing in. So I'm going to go ahead and accept that. And now when I start debugging this particular problem, see that I've failed. The debugger did not break like it did last time, and when I look in the output window, I can see that it printed the message that I just mentioned. So encoding was not in curly braces or didn't have a $sign in front of it. So I see the word encoding here. I can see that byte to mask and mask were turned into their appropriate values. So 75 is encoded to 128. And then because I had the pseudo variable function, that's now been expanded out to be the actual function name that the debugger was executing in. And actually by doing this, I'm able to see the bug for why it's failing on character 75. And that is because 128 is not a valid ASCII character. So I'm doing ASCII encoding here, so I need to add some modular arithmetic to my application in order to fix that. Well, that's all the time we have for now, but I'd like to encourage you to try out Visual Studio 2015 and let us know what you think about the changes for configuring breakpoints. You can always find detailed information about all our new features on the Diagnostics channel of Visual Studio ALM blog and communicate with us via Twitter @VS_debugger. Thanks for watching.